Good morning students. Last class we saw that reverse bias and forward bias, right? Now let us discuss about the rectification. What is mean the rectification? Rectification means the process of the converting alternate current into the direct current. So AC we are converted to the DC, that is we are said to be that rectification. Okay, wow. So you have some example of you take that our home current is home current value is 220 volt. Okay, I think you know that 220 volt each house coming to the current voltage 220 volt. You know that is a alternate current, that is a AC current, alternate current only. Now we use that mobile or laptops, some of the electrical items. Example you take to the mobile phone. Nowadays we are using to that mobile phone is here for the more purpose we are using, right? For online class also, right? So now we want our mobile is here direct current. Okay, what is how I am telling to the, we are using to the battery. Okay, we are using to the battery, so it is a direct current, so DC only. Okay, now you see that after that battery charge is reduced means we use into some of the plug and the switchboard we are using to under switch on means what happens, immediately that mobile charges here charging. Okay, so now what happened, the mobile is having to the DC, so but our current coming to the AC. Okay, so the AC converted to the DC current. So our homes coming, the current, total current value is here 220 volt. 220 volt. So that is first what doing means, the rectifier what doing means, first it's here the 220 volt, how much we need. So example of the 20 volt we need means, first the AC current 220 is converted to the 12 volt AC current. After that we are using to the some of the diodes, that is a PN junction, that is last class can saw that, right? Okay, so that PN junction we have to using. So next it's what happened, the AC current we are changing to the DC current. Okay, so that is a rectifier, that is a rectifier. Okay, rectifier. Okay, now you see that so now you see that the AC current we want change to the DC current means which one is a need, it's a transfer, it's a very important, the transfer is a very need. Okay, so now the one put diagram. So you see that this is a AC current, this is what the, it's a conjunctly we are putting that crust we are putting that is what the transfer. So this is the transfer given 220 volt. Example of the house given to them, which one given to the transfer, transfer to the 220 volt in the each house, right? Okay, so this is that. So this is what means, it's a step down current, step down. This is a step down. You see the small, so all the curve is here, each one is a gap, so this is a step down. Okay, so what happened, the 220 volt AC we are converted to the 12 volt AC, you have to changing. After what we are doing, this here the here plus or here minus, we are connected to that one diode, that is a PN junction diode. It is a rectifier to AC converted to the DC. This is a rectifier. Okay, so after that what happens, so going to the current is here through that this is what means load. So load means what application, what appliance we are using, that appliance load. So now we are charging to the cell phone means it is a cell phone. Okay, RL we are denoted that is what appliance, electrical, whatever appliance we are using, that appliance we are telling here load. Okay, this is a rectifier. So simply what means a rectifier means the AC current converted to the DC current, it's using to the that is we are called to the rectifier. Okay, this is a rectifier. Are you clear? Okay, now you see that so the rectifier base pani we are doing to the very important questions, 5 mark questions, half wave rectifier and full wave rectifier. So you see that it's a very important one, every year coming to this questions, half wave rectifier circuit and full wave, the full wave rectifier. It's a very important. Half wave, it's a one of the 5 marks, so full wave is a one of the 5 mark. Okay, now you see that half wave. First we are discuss about half wave rectifier. Okay, half wave rectifier, this is we are telling to the unidirectional. Uni means what? Single, one side only, the one side only the current is passing, another side it's not a passing. Okay, so one side only passing, so that's why we are telling to the unidirectional. So half wave rectifier, how what we are telling? Unidirectional. So you see that this is a AC, that is means what? It is a transform. Okay, AC it's a input, it's a transformer. Okay, it's a transformer. So now you see that the AC. So next AC we have to connect to this point is a, this point is a B. So the A it's a connected to that this anode is a PN junction. So long line, you know, that is, this is a diode, this is a long lines coming, that is a positive, that is means anode. So we are thinking mention that anode. So next the sharply having the edge, okay, that is a negative charges, we are telling to that cathode. Okay, so now you see that the join to that going to that the plus value. So next you say here the one connected to the RL, that is a load. Okay, load connected. So now next we are going to the connected to the RL going to connected to the ground. Okay, now you see that first we are applying to the AC current. So now you see the AC current, the AC current. So one side only it's a passing to the current. You see that this side only going to the passing current, this side not going to the passing current. So that's why we are telling the unidirectional, the single way. Okay, so now you see the example we are taking to the 220 volts here. That volt, that AC 220 volts we are converted to the 12 volt, that is a AC converted. Okay, now here it's a going to that the positive in positive charges is a going to that here. So here also positive, here also positive. So positive charges means what bias? This one forward bias. Okay, the forward bias, what happened? The forward bias only positive and negative. It's a what happened? It's a conductor to the current. So the positive charges are going to the negative charges going to here. So next what happened? It's going to the RL load. Okay, so the appliance is a working, it's a passing to the current. Okay, this is what this is a half wave rectifier positive cycle. That is a what? Positive cycle. So this is we are telling to the positive cycle. So that is half wave, positive half wave cycle, positive half wave cycle. Okay, so only the single wave only we are moving that. Okay, this is the half wave cycle. So now that we are doing to the solenoidal graph. So solenoid graph you are know that Kraft and Truft. Okay, so now you see that Kraft and Truft coming. So now this is a AC. Let's say this is a positive, is negative, positive, negatives. Okay. So now here we are given to that you are changing to that minus value we are given means what happens? Say attracting. So attract means this bias what changing that reverse bias change. So reverse bias means what happens? So not a conducting to the current. Okay. So it's not a flowing to the current. Okay. Now you see that that is a DC. So first what happened? The forward bias means the current is a going. After that negative means what happened? The reverse bias not a not a conduct to the current, passing to the current. Okay, so this is so again what of the positive. So this is a going on up and down here. Okay, now finally the efficiency we have to find out. So how to here find out the efficiency means here input, here output, right? So output divided by input. So output divided by input. The efficiency how to here find out? Output divided by input. So here I change into that. Here what happen? Output means DC divided by AC. DC divided by AC. Now you see that the efficiency of percentage 40.6%. It's a very important one. This question is a very important question. It's a 5 mark come. Okay. So now you see that next one is a full wave rectifier. So next you see that full wave rectifier. Now you see the full wave rectifier. Here also we are using to that full wave rectifier. Now both side is going to the current, both sides. So this side also moving to the current, this side also the moving to the current. Okay. So now you are taking to the water. This is the transformer AC, the transformer of AC. The here is a AC also, the 220 volt AC converted to the 12 volts. Okay, so now you see this diagram. This point here you are connected to that. First you are connected. Here put the names M, here N. Next diode. Here also one diode. That this diode is a D1. This diode is a D2. So next it's a connecting to some of the wire connected to the D2. So next the long wire connected to the A. So diode and A in between we are connected to the resistance load, that is the load. So next the connector, the RL is connected to the ground. Okay, so next is the second diode, it's a connected through the B. Okay, so next here the center of the wire non connected to that C. So the C is here what on the center tapped transformer. C means is what? Center tapped transformer. Okay. So what doing this C means? The C is a splitting to the current. So ipdi anupu. Okay, so it is splitting to the current. Okay, so that's time we are using. So now you see that the AC current is here changing to that current. Okay, so 220 AC current is here changing to the AC current 12 volt current we have to changing. Then that current is here moving to the M. So the positive charges are moving to that diode D1. So the M is a positive, the diode is this side also positive. The positive what happened? It's a conductor to the current. It's a through. It's a going to that wire of the A. So next what happened? The A it's here given to the load RL. Already given kodukradhu. Immediately it is here passing to the ground level. The ground level is going to here. Inga or line connect pannirukku parunga, center taped transformer. So adu valiya enagudhu, it's a passing through here. Okay, so again it's a what happens? It's going to the positive current. So this process here, it's a moving to that. So this bias what here plus means what bias here using? It is a forward bias. It is a forward bias. The forward bias only conducting to the current. So the simultaneously you see that M. So M is here negative. So here also positive. So negative and positive. What happened? It is not conducted to the current. So this side not moving to the current. Okay, so next what we are doing? It's a alternate changing. So we have to change into the alternate. What happened? The M is given to the negative charges. N is given to the positive charges. So what happened? Here the M is here negative charges. Here the diode D1 is here positive charges. So what happened? Negative plus positive. So what bias? This one is here reverse bias. So here not conducted to the current. So here not conducted to the current. So next what happened? Down you see that the N is here positive. The D2, the diode 2 is here positive. So both is here what happened? Positive. So it is a forward bias. So this bias is a forward bias. So it's a converted to the current, is a pass through to here. So what happened? The here one line going on. So here this line moving and here moving. RL it's going to the ground level. Then the C, the center of tape transfer, no, it's going to here. So this side again it's coming to that, so moving here, coming, so this is the what, the forward bias. So then it is okay, it's alternate. First the off cycle of the bias, you see that off cycle of the bias, off cycle bias, how to we are calculating m d, first one the off cycle, no, m positive bias, m positive bias, m d1 a and g, okay va. So next n d2 b g, okay, c, okay va. So this is the cycle. So next you see that so the graph is what, the crust and trough, it's going to the is a plus minus plus. So DC la what happen, the positive is here going to the current, negative going to the current, the positive going to the other. This side coming only here, continuity this one, it's a keep on moving that, okay. This is a very very important question. I hope you are understood that rectifier, half wave rectifier, full wave rectifier, it's a very very important questions. Be thorough it. Thank you children.